Students, today I am going to inform you all. I am going to explain about your third chapter in geometry, that is circles. Let us revise which are the basic concepts with respect to a circle. Circle is a set of points which are at a fixed distance from the fixed point. The fixed point is called as the center of the circle, and the distance from this circle to any point on the circle is called as radius. In this figure, segment OR is radius, CD is also a segment, but it joins two distinct points of the circle. The segment joining the distinct points of the circle is called as chord. Diameter is also a chord which passes through the center of the circle. Diameter is the largest chord of the circle. When the chord is extended on both sides in the form of line, the figure that we get is called as secant. So secant is a line which intersects the circle in two distinct points, whereas tangent is a line which intersects the circle in only one point. In this figure, line L is the tangent and line S is the secant. Now some properties as well as theorems which we have revised in 9th standard. I'll go through those properties. What does the first property tell us? If two chords of a circle are congruent, then they are equidistant from the center. In this figure, AB and CD are two chords which are congruent, and if O is the center of the circle, then they are at the same distance from chord AB as well as chord CD. That means segment OP is congruent to segment OQ. If two chords of a circle are congruent, they are equidistant from the center, and its converse is if two chords are equidistant from the center, then they are congruent. Chords are congruent, equidistant from the center. Chords are equidistant from the center, then they are congruent. Another important property. Based on circle, which you all have studied it last year in the form of theorem, is segment joining the center of the circle, or line joining the center of the circle, or a ray joining the center of the circle and perpendicular to the chord bisects the chord. In this figure, O is the center of the circle, segment OM is perpendicular to chord AB, hence AM is equal to BM. It says that the line joining the center of the circle and perpendicular to the chord bisects the chord. Its converse is also true. Line joining center of the circle, and midpoint of the chord. M is midpoint of chord PQ and C is center of the circle. This line joining center of the circle and midpoint of the chord, it is perpendicular to the chord. Exactly converse of the first one. Line joining center of circle and perpendicular to chord. What it will do? It will bisect the chord. Its converse is again line joining center of the circle and midpoint of the chord. then it is always perpendicular to the chord. Now, in 10th standard, we are going to study an important theorem which is based on circle and tangent, which is also called as tangent radius perpendicularity theorem. What does the theorem tell us? If a line is tangent to the circle, if a line is tangent to the circle, line L is tangent to the circle at point T, O is the center of the circle, then let us consider a point R which is outside the circle. Line L is tangent to the circle at point T, therefore this line is always perpendicular to the radius of the circle. It tells us that if a line is tangent radius theorem. If a line is tangent to a circle, it is always perpendicular to the radius of the circle. Now, using this, if I join O to R, I get a right angle triangle. And making use of Pythagoras theorem, if any two values are given, I can find the third value. If OR and TR are given, I can find OT. Or if OT and TR are given, I can find OR. Or if OT and OR are given, I can find TR by using Pythagoras theorem. That means I can find the longest distance as well as the shortest distance from the center of the circle. Its converse. What does its converse tell us? If a line is perpendicular to the radius of a circle at its outer end, if a line is perpendicular to the radius of a circle at its outer end, O is center of the circle, OP is the radius. If there is a line which is tangent to it, then it is perpendicular to the radius. Converse is, if a line is perpendicular to the radius of the circle at its outer end, then that line is tangent to the circle. If OP is perpendicular to line L, then line L is tangent to the circle. Another important theorem which is connected with tangents and circle. To know this theorem, let us consider another aspect with respect to tangents and circle. If a point lies inside the circle, O is center of the circle, Q is a point. Through Q, I cannot draw any tangent. If a point lies inside the circle, no tangent can be drawn. If a point lies on the circle, only one tangent can be drawn. If a point lies outside the circle, then two tangents can be drawn to the circle. I can draw two tangents to the circle. If a point lies outside the circle, two tangents can be drawn. If a point lies on the circle, only one tangent can be drawn. If a point lies inside the circle, no tangent can be drawn. Now, using this, the tangent segments drawn to a circle from an external point are congruent. If you are given a circle with center, let us say C, and P is a point outside the circle, the tangent segments that are drawn to the circle